So welcome back. So in our last week's video, we did the standard statistical measures for these quantitative variables. And aside from the count and the mean and the standard deviation, the rest of this is what's called the 5-number summary. It's what's used to make box plots, and it gives a nice kind of how spread out where the data in general is. What we're going to do with percentiles is just refine this a little bit. So each one of these numbers in the 5-number summary, the min, the 25th percentile, 50th percentile, etc., all the way up to the max, these are all percentiles. The min is the 0th percentile. The max is the 100th percentile. So these are already the default percentiles. What we're going to do for this next bit is tell Python specifically what percentiles we want it to show. And so I'm going to set that up right away. I'm going to say that the percents that I want to show are going to be, and so I'm going to make a list of numbers. And so I surround the list with these square brackets. And then the percentages that I want to do are 1%, 5%, and I'm writing them as decimals rather than percents. So 5%, I want 10%, I want 25% and 50% and 75%. I want those like normal. And then the corresponding, so just like 10%, I'm going to write 90%. Just like 5%, I'm going to write 95%. Oops, not 9 point. I don't even know what that was. There we go. 95% or 0.95. And then finally the 99th percentile. So these are the percentiles that I want to do. And I'm noticing a typo. Maybe some of you were screaming at me from your end, but I have an extra 0 on my 25th percentile. Okay, so I'm setting up what percents I want. And now it's basically the same command. And I'm going to need to name it something different because it's a different thing. And I want to hold on to what I've done before. So maybe instead of just descriptive for the diagnosis age, I'm going to do percentile for the diagnosis age. So I'm going to use that. Oops. Okay. And inside this describe, I'm going to give it the constraint that I want the percentiles be equal to this percent that I just set up. So percents. Okay. And then I want to print that. Percentiles diagnosis age. That's what I want to print, this thing that I just created. And there it is. It's kind of the same thing. And it is going to still have the min and the max, but then it's going to have all these other percentiles mixed in. So we can say that 99% of these 783 people had their diagnosis age less than or equal to 29 years old. And if I look at the first percentile, there were a lot of babies that were getting diagnosed, and we saw that with the histogram as well. That was one of the modes was 0. But whereas there's quite a few ages up here at the top, all kind of spread out. That last percent is kind of spread out. Here, both the min and the first percentile are both 0. Get up to the 5th percentile, and 5% are less than or equal to 1-year-old. All right, so there's that one. I'm going to do the exact same thing, but for my other variable, my other quantitative variable. So that's percentile for sibling number. And I think on this slide, I just call it siblings. So I'm just going to call it siblings. What variable am I doing this with? Sibling number. I have to get this exactly right or it's going to mess up. But I don't need to change this because I've already laid out what percents I want in my different percentiles. And so that's going to be the same. I just then on here have to use this name that I created for this object, this output that this function is going to do. So when I do that, we now get the sibling number with all those different percentiles. All right, hope that made sense. Good luck on the quiz, and I'll see you later.